Hi, welcome to this new lesson. This time I will talk about streaming processing and I will follow the same model as previously for batch processing, and hopefully in the end of this lesson you will be able to understand the differences and the situation where you should use one or another. So to start, few basic points. So the first is that streaming processing applies mostly to the data in motion. What does it mean? It means that the data is continuously arriving to your data source, and in consequence, you have to process it also continuously. So the data in motion is the thing, a term that we can use to describe the data that never stops. You may take an example of, so you can take an example of Apache Kafka topic, which is a kind of distributed append-only log with some storage units called partitions. And in that case, data is continuously arriving to the partitions, meaning that there is no moment where these partitions are considered closed and the data stored there is considered as immutable, so meaning that there is nothing more that will come. Of course, this might happen if the data producers decide to not ingest the data anymore to this place, but anyway, we are talking here on something unexpected in streaming processing because by definition, the data is supposed to come continuously and without interruption. The second point is related to this data in motion. It's a kind of side effect. You need to have a continuous execution to process this data. And this continuous execution brings something else. It brings low latency because as the execution is continuous, it doesn't stop and you can have the data, you can have the insight from the data much more earlier than for the batch processing, which is kind of scheduled either every 30 minutes, every hour, or a very high latency. And it involves another thing, so the data is processed continuously, and it involves smaller volumes of data per processing unit, so per task. And it really depends on the streaming paradigm you will use. You can either process data at an element basis, so whenever one item comes to your streaming job, or per micro batches. In that case, you will have more data to process in a single execution, but still the volume will be much lower than for batch processing, and that's why we talk here about micro batches, so a smaller, tinier version of batch. And it's worth noting that the data in motion can become a data at rest in the case when you decide to synchronize your continuous and data in motion source to some data at rest storage, like for example files, a distributed file system, or maybe a database. So in that case, the data becomes fixed, static, and it can be processed by batch jobs at higher latency. So the example of a streaming pipeline is very similar to something you already saw before for batch processing, except two, maybe three different things. So the first is there is no schedule. The pipeline is running continuously. The second one is that the data processing logic may require some extra storage and some extra capacity, because if you want to implement this pipeline in batch, you will have your job running for a while and after that it will stop. So you will need to store for example, the state for previous counter or for previous sum physically in a persistent manner. Here, because you are processing data in streaming and inherently you are requiring low latency, it's better to have this information in a faster access storage, like for example, a main memory. And so the algorithm is also a bit different because of that. Still, we start by reading the data, but later we are getting the last state from memory, and we are updating the aggregate we want to compute, for example, by users or by maybe store IDs, something like that. And in the end, we are writing this output. This output, it's very important to notice, is incremental, meaning that if we take an example of a number of times a user visited a page in our e-commerce store, each execution of the step 4 will or should, for the given user, if it's still active on the e-commerce in our e-commerce store, should update its previous counter. So it may never be, in fact, the final result. It still may be something that it's alive and incremental. On the other hand, if you have the batch pipelines, you rather think in terms of finished data at rest. So the data you generate in the output is very likely to be your final outcome, unless of course there is some corner cases, like for example a late data integrated to your batch pipeline, where if you integrate it, the output will not be final in the first run, but only when you integrate the late data. But please not bother, I will not bother with but I will not bother you with this in this lesson. In this module, it's more basics, one-on-one module, so covering basics. I will talk about late data later in the course in other modules. And to illustrate, and the streaming pipelines also naturally fits into this ETL model. So we have some extract, transform, and load steps. And more specifically here, we can see that we are reading streaming broker, so streaming data source, and we are writing to streaming data source. But we can also imagine a case when we write to some data addressed storage. As I said previously, we may need to synchronize streaming data with data address storage for batch processing, but we may also need to generate some data in real time and expose it to, for example, an API service that will be better in querying it from, for example, a key value store or an in-memory database. And another, a little bit variation of this pattern is that when you mix streaming and batch, so we can imagine a batch pipeline here, so the streaming broker that uses some data which is created by a batch pipeline in a data addressed storage in order to do some data enrichment and expose more valuable information to the end users in these TL steps. So to sum up, some final thoughts about streaming processing. So the first one, very important thing, is that if you need low latency, you have no choice, you must use streaming, because as I said before, it guarantees latency from seconds to maybe small dozens of minutes. It also a good solution to loosely coupled component, because generally when you have streaming, you have a central streaming broker that is a central data provider for other pipelines. There is no direct interconnection between jobs. And finally, it's also a way maybe to use less compute resources, because as I said before, the result is more incremental. It doesn't require the whole data set to be available for processing. And among the cons, there is some operationalization overhead, especially when it comes to reprocessing. Very often the reprocessing pipelines for streaming jobs are defined as batch pipelines working on the data addressed when the data from streaming brokers is synchronized. There is maybe also a bit difficult to detect and to keep data quality, because streaming is most to provide data in real time, and each thing you add to this business value, to this value generated for the business users, like for example technical data quality checks, it may slow down the whole process. And finally, there is some extra complexity for operations that appear to be very rudimentary, very simple in batch and in data address, like for example joins and aggregation, when you might, because of the temporal character of streaming, they require some kind of synchronization between the data sources to know when one side, for example, will not receive the data to join, and in that case it has to be returned to the output. But again, it's a complex topic. I will cover it later in this course. And that's all. I hope that now you see some differences between batch and streaming processing, and if it's the case, I hope you will join me in the next lesson. Thanks for watching.